Kalau saya kalau saya terlaju ke apa, nanti inform saya Okey, yang tak dapat scan nanti PM saya PM saya lepas habis kelas Okey. Alamak, saya lupalah. Kita ada international student tak? Do we have international student here? Tak ada. Ni semua masih mamai-mamai lagi ke ni? Okey. Okey, so kita sambung kita punya lecture. Masih lagi chapter 1. Okey. Last week kita tak ada kelas sebab public holiday kan? Okey. So actually kita dah cover chapter 1 sampai item number 5. Okay, so hari ni kita nak tengok decibel and power. So this topik ni memang sangat penting So you all kena master betul-betul decibel, macam mana nak convert daripada watt ke dB and then ke dBm. Okay, lepas tu nak convert balik. Okay, macam mana nak kira power. Okay, sebab nanti kita akan pakai banyak dalam chapter 2. Okay. Okay, sebelum saya start dengan last topik ni, so ada soalan tak? Any question regarding last 2 weeks punya lecture?
Tak ada, Doktor.
Tak ada Okay. Okay, so can we start? Boleh kita start Okay, so this week, okay, so gain. What is gain? Gain dalam bahasa Melayunya gandaan. Okay, gain is a ratio, okay, output to input. Macam, let's say you have, okay, you ada input signal kat sini kan? Okay, sini output. This one is your amplifier. So gain is calculated by, kita calculate gain by V output, kita punya output divide by input. Okay, so ini adalah gain. Okay, and we will call it gain if the output is greater than input. Okay, kalau output awak lagi besar daripada input, kita panggil dia gain. Gandaan, right? Daripada kecil, kita gandakan jadi besar. Let's say, daripada 1 masuk, kenapa dia tak ni? Okay, daripada 1 masuk, dia keluar jadi 2. So, ini gandaan. You gandakan input. Okay, so, for gain, okay, you punya ratio dia mesti greater than 1. Okay, so kalau you buat ratio antara output and output, you will get greater than 1. Because output is greater than input. Okay, so that is amplifier gain. Okay. Okay. So, ini dia punya rumus dia. Okay. AV. Okay. AV is a V out over V in. Okay. If you have power, AP equals to P out over P in. Okay. If you have voltage, then you will use V out over V in. If you have power, you will use P out over P in. Okay. To calculate, this one we'll call it power gain. Okay. Sebab kita calculate guna power. Okay. Ada soalan tak? Ingat gain, okay, adalah output divide by input. Okay. Okay. So, kita tengok contoh ni Okay, so contoh ni, kita ada 1, 1, 2 and 3 amplifiers. We have 3 cascaded amplifiers. Okay, so look at the first amplifier. Okay, you have input voltage 1 millivolt and you have a output voltage 5 millivolt. Okay, so saya label kat sini V out 1. So your V out 1 is equals to 5 millivolt. Okay, then you boleh dapatkan dia punya gandaan A1 equals to VO1 divided by V in. Right, betul? V out divided by V in. So what is your V out 1 is 5 millivolt and then divide with 1 millivolt. Then you get A1 equals to 5. Betul? Betul?
Betul.
Okay.
Betul.
So A1 is 5. This one. Okay. Okay. Because this amplifier is connected as cascaded here, so this output will become input for this amplifier. Okay. So this one will be V in 2. Okay. V in 2 equals to V out 1 here. Okay. And this is your V out 2. Okay. And A2 equals to V out 2 divided by V in 2. Okay, so what is V out 2? V out 2 is 15 millivolt. Okay, so 15 millivolt here divide with V in 2. So V in 2 is equals to V out 1, which is 5 millivolt. Okay, so divide by 5 millivolt. And then you get A2 equals to 3. Okay. Kalau tak faham boleh interrupt saya anytime. Okay, and then we have third amplifier here. Okay, so this V out 2 will become input for this amplifier. So we label it as V in 3. Okay, and this one will be V out. Okay, so A3 equals to V out divided by V in 3. Okay, so what is V out? V out is 60 millivolt. Okay, so 60 millivolt divided by V in 3 is equals to V out 2, which is 15 millivolt. Okay, so 60 divided by 15, you get 4. Okay, so your A3 equals to 4. Okay, so now you have A1, A2, and A3. Okay, you can get the overall gain. Okay, total gain is AT. Okay, so AT equals to, equals to A1 times A2 times A3. Okay, so equals to A1 is 5 times with 3 darab dengan 4. Then you get, berapa you dapat? 15 times 60. Okay, dia tak ada unit Okay, no unit. Okay, untuk gandaan tak ada unit. Okay, so you get total gain is 60. Okay, this one kalau you kira salah satu. Okay, awak boleh juga dapatkan AT. Okay, okay, you know this is the output and this is the input. Okay, so you direct use this output and this input. You will get also the total gain. Okay, V out divided by V in, which is 60 millivolt divided by 1 millivolt. Okay, you get 60. Okay. Ada soalan? Any question regarding this slide?
Tak ada, doktor.
Tak ada.
No,
Okay.
doctor.
Okay. So kita tengok example ni. Example 1.1. Okay. What is the gain of an amplifier, okay, that produce an output of 700 millivolt for 30 microvolt input? Okay. So apa dia nak? Okay, kalau amplifier, you know the symbol. Okay, symbol dia macam ni kan? Okay, so this is amplifier. You have the input. Okay, given here input is 30 microvolt. Okay, and the output is 750 millivolt. Okay, okay, so dia nak gain. So we know that gain A equals to V out divided by V in. So what is V out? 750 millivolt divided by 30 microvolt. Then what is the answer?
25K.
Berapa?
25,000.
Okay. So you get 25K. Okay. Faham Okay, kalau faham kita tengok example 1.2. Okay, example 1.2 is the power output of an amplifier is 6 watt. Okay. So now you have an amplifier here. Okay. And the P out equals to 6 watt. Okay. And the power gain is 80. And given here A equals to 80. So what is the input power? So dia nak P in. Okay. Okay, we know that A is equals to P out divided by P in. Then we just rearrange back this equation so that P in equals to P out divided by A. Betul? Betul kan?
Betul, doktor.
Okay. Then what is P out? P out is 6 watt. Okay. Divided by 80. Then you get P in. So what is P in? 6 divided by 80.
0.075.
0.075.
75 milliwatt. Betul?
Betul.
Betul.
Okay. Okay, next is okay, we have 3 cascade amplifier. Okay, and the power gain is 5 to 17. Okay, the input power is 40 milliwatt. What is the output power? Okay. So dekat sini dia ada 3 amplifier. Okay. A1 2, A2 2, A3 17. Okay. And the input power is 40 milliwatt. Okay. And dia nak dapatkan P out. What is P out? Okay. Okay. So, apa you nak buat adalah you have to calculate the total gain. Okay. If you have a cascaded amplifier, okay, and you want the output or the input, okay, you have to calculate the total gain. So, what is total gain? AT equals to A1 times A2 times A3. Okay, which is, sorry, this one not 2, 5, right? Yang ini. A1 is 5. Okay. So 5 darabkan dengan 2 darabkan dengan 17. So what did you get for 80, 10, 170, betul? Kan? So your total gain is 170 and the input power is 40 milliwatt. Okay? So we know that A equals to P out divided by P in. Okay? So P out is equals to A times P in. Right? Kan? Okay? So A is 170. You darabkan dengan P in is 40 milliwatt. And you will get P out equals to
0.8.
170 darab 6.8 watt, betul tak? Betul eh? Okey, ada soalan?
Betul, Doktor.
Tak ada eh? Senang kan? Okay. Okay, next is attenuation. Okay. The calculations is the same as again. However, for attenuation is dia punya ratio A, V out over V in is less than 1. Because output is smaller than input. Okay, attenuation is a bahasa Melayunya apa eh? Pelemahan eh? Okay, something like that. Okay. So attenuation is referred to loss that introduced by circuit. Okay, you have circuit. Okay, so every circuit will produce loss because you have the resistance, right? Okay. Okay, konsepnya sama. Okay. Attenuation equals to V out over V in. However, here it's stated that output is less than input. Therefore, the ratio is less than 1. Okay. And also for cascaded circuit, okay, total attenuation is calculated like this, same as a gain. Okay, sama macam gain. Okay. And okay, ini you all dah belajarkan dalam circuit theory. BEV pun ada kan? Power pun you belajarkan circuit theory kan? So voltage divider. Okay, you know voltage divider? Okay. So this voltage divider, okay, we refer it as a attenuation circuit. We calculate the attenuation introduced by this voltage divider. Okay. Okay, kalau you tengok dekat sini kan, this is the voltage divider. Okay. You have two resistor here, R1 and R2. Okay. And you have an input voltage here, and this is the output voltage. Okay, we know that A is V out divided by V in. Okay. So V in is this total V in. Okay. And V out here, okay, kita calculate by, kita dapatkan dia punya V in equals to R2 divided by R1 plus R2. Okay. So this is V out. Okay. And A, okay, so ini V out eh. So this is V out. V out is a R2, okay, divide by R1 plus R2. And then kita darabkan dengan V in. Okay. Okay. So V out, V in. Okay. Kalau you bawa V in to this side, you will get V out over V in equals to R2 divided by R1 plus R2. Okay. Then the V out over V in is the A. Okay. So you dapat A is actually attenuation for the voltage divider is equals to R2 divided by R1 plus R2. Okay, and from this circuit we can get A. Okay, we know R2, we know R1, then we can get A. So A equals to 100 divided by 300, and then you get 0.33, which is less than 1. Okay. Ada soalan? Any question? Tak ada.
Tak ada, doktor.
Okay.
Oh, doktor.
Okay, you all semua ni dah breakfast belum ni?
Ya.
Okay. Okay, now kita tengok. Okay, this circuit. Okay, we have 3 cascaded circuit. Okay, so A1 is 0.2, A2 0.9, and A3 0.06. Okay, if you look at the value here, okay, by looking at this value, we know that this is the attenuation circuit. Okay, this is attenuation because the value for A is less than 1. Okay, and then you have the input 3 volt. Okay, and here you have V output, V out. Okay, okay, you can get the total total attenuations. Okay, AT equals to 0.2 times 0.9 times 0.06. Okay, then you get AT equals to 0.0108 here. Okay, you want to get V out. Okay, macam biasa, you know the basic equations is A equals to V out over V in. Okay, then you can get V out. So V out equals to A times with V in. Okay, A here is a A total. Total attenuations occurred in this circuit. So V out equals to AT times with V in here. Then you get V out, 32.4 millivolt. Okay. 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 And also, okay. Okay, kalau you tengok dekat sini, okay. This is the voltage divider. Okay. You have V in, okay, and also V out here. But here we have the gain. Kenapa kita ada gain? Why do we have a gain? Because we want to produce V out equals to V in. Okay, so if V out equals to V in, what is your A? If V out equals to V in, so what is the value of A?
1.
Anyone? What is A for V out equals to V in?
4.
Berapa?
4.
A must equals to 1. Okay, A mesti sama dengan 1 supaya V out kita sama dengan V in. Okay, what is apa yang masuk, itu yang keluar. Okay, dia tak ada lebih, tak ada kurang. Okay, so your A must equals to 1. Okay, so V in, okay, we know that this part, okay, so here I put it as V out 1. Okay, so this part is the attenuation. This part is a amplification. Okay, so we look at the attenuation first. So V out 1 is actually equals to, here you have a A1, right, for attenuation. This one A2 for gain. Okay. Okay, so A1, what is A1? Here, okay, A1 is equals to R2 divided by R2 plus R1. Okay, you get A1. Okay, so what is R2? R2 is 250 ohm here. Okay, R1 is 750 ohm. Okay, so R2 divided by R2, R1 plus R2, then you get A1. Okay, and A1 is 0.25. Kan? Then you dapat A1 is 0.25. Okay, A1 is less than 1 because this is the attenuation. Okay, okay, now, okay, this is 0.25. Okay, we know that the total gain must be 1. Okay, total gain must be 1. Okay, for that V out equals to V in. Okay, so now we know that AT equals to A1 times A2. Right. Okay, so now kita dah ada A1. Okay, if we want to know what is A2, okay, so A2 equals to AT divided by A1. Okay, so what is AT? AT is 1 here. Okay, so the total gain must be 1 because we want V out equals to V in. Okay, then AT is 1 divided by 0.25. Then you get A2 is 4. Okay, so for total gain, okay, 1, okay, you need the amplifier with a gain 4. Okay, so here is 4. Okay, faham eh?
Faham, Doktor.
Faham eh? Okay. Okay. Okay, previously kita tengok separate attenuations and gain. Now, okay, actually the gain and amplifier, okay, we can mix together in one circuit. Okay, so here we have an input, okay, 1.5 volt, and we have A1. A1 is 0.1. Okay, so if 0.1 less than 1, we know this is an attenuation. Okay, and then we have an amplifier, okay, because the value is greater than 1. And here we have the attenuation again, okay, 0.3. And here is an amplifier with 15. Okay, gain is a 15. Okay, and then this is the output. Okay, the overall output is 6.75 volt. Okay, okay, you can get the attenuation, the AT. Okay, AT. AT is equals to A1 times A2 times A3 times A4. You can directly darab the value of A4, A3, A2 and A1. Awak boleh darab terus je. Tak kisah di attenuation ataupun amplifier. Okay? Okay. Faham eh? So this one input is 1.5. Okay? Then the output will be, kita tahu kan A equals to V out divided by V in. Okay, then V out equals to A times V in. Okay, so here output equals to A 0.1 times 1.5, then you get 0.15 volt. Okay, and then you times again with 10, okay, you get back 1.5 volt. And then you times with 0.3, you will get 0.45 volt. And then you times this one with 15, you'll get this one, the overall output. Okay. Okay. Okay, kalau okay saya move to next. Okay. Example 1.3. 4. Okay. So 1.4, you have a voltage divider. Okay. Which figure? This figure. Okay. So you have a voltage divider. Okay. The value of R1 is 10 kilo ohm and R2 is 47 kilo ohm. So you have the voltage divider here. Okay, so this is a V out. Okay, this is R1 equals to 10 kilo ohm and this is R2 equals to 47 kilo ohm and this is the V in. Okay. Okay, so the first question is what is the attenuation? Okay, so we know that attenuation for voltage divider is A equals to R2 divided by R2 plus R1. Right. Then A equals to R2 is 47 kilo ohm. Okay, divided by 47 kilo ohm plus with 10 kilo ohm. Okay, so what is A?
Zero
47,000.
0.8225.
Berapa saya tak dengar?
0.824.
0.8. 24. Okay, so you get A equals to 0.824. Okay, so this is your A. Next is what amplifier gain would you need to offset the loss for an overall gain of 1? Okay, so ini awak punya ni and now dia nak tambahkan gain supaya you punya overall gain AT equals to 1. Okay. So dia nak tambah amplifier kat sini. Okay. So that your total A is equals to 1. Okay. So now you have the A1 is 0.824. Okay. We know that AT equals to A1 times A2. Right. A1 is the attenuation voltage divider here and A2 is this one. Okay. From your amplifier here. Okay. So your A2 is equals to AT divided by A1. Betul tak? Sorry. Divided by A1. Betul?
Betul, Doktor.
Betul Okay. So AT is 1 divided by 0.824. Then you get
1.2.
berapa awak dapat? 1 bagi 0.824.
1.214.
1.214 betul? Betul tak?
Betul, Doktor.
Yes, yes.
2.214. Okay, so your gain must be this value so that the total gain here will be 1. Okay. Okay. Okay, kalau okay, we move to next example. Okay. Example 1.5. We have an amplifier, okay, with gain 45K, okay, and which is too much for amplification, okay, with an input voltage of 20 microvolt. What attenuation factor is needed to keep the output voltage from exceeding 100 millivolt? Let A1 equals to amplifier gain. Amplifier. Okay, A1 is an amplifier. And the gain is 45K. A2 is attenuation factor. AT is total gain. Okay. Dapat soalan, fahamkan soalan. Okay, you have an amplifier here kan? Awak ada amplifier. Okay. Input voltage is V in equals to 20 microvolt, and the amplifier gain A1 equals to 45K. Okay. So this amplifier value is very high. Betul? Then we need the offset. Okay. So that the output voltage is not exceed this value. Okay. Okay. So this is amplifier. You need attenuation here. A2. Okay, but you don't know what is the value of A2. Okay, but you know that the output voltage must be the maximum is 100 millivolt. Right. This is the maximum output voltage that we can get. Okay, we cannot exceed this one. Okay. Okay, then we know this one is the maximum output voltage. We know that this is the input. We can get the AT. AT is equals to 100 millivolt divided with 20 microvolt. And what is the AT?
RM5,000.
Berapa?
5K, doktor.
5,000.
Tak dengar. Saya punya ni speaker ni tak dengar lah.
5K.
Kenapa? Berapa?
5K.
5,000.
2,000?
5.
5K.
5,000 eh? Okay. Then we have a AT equals to 5,000. Okay. So AT is A1 times A2. Okay. Then A2 equals to AT divided with A1. Okay. So AT is 5,000 divided with 45K. Okay, what is A2? 5,000 bahagi 45. 0.1111, betul?
Betul, doktor.
Doktor.
Okay. So this is your attenuation factor that you need, okay, to keep the voltage from exceeding 100 millivolt. Okay, ada soalan? Faham example 1.4 dengan 1.5?
Faham, doktor.
Okay. Okay, next is decibel. Ini you all dah biasa kan? Okay, dah biasa dengar decibel kan? Okay, so decibels, okay, kita pakai untuk express power, gain and loss. Okay, so the conversion is, kita tahu nilai, kita ada nilai, okay, 10 log nilai tersebut. Okay. Okay, contoh dia macam ni. For example, you have 2. Okay, and then you want to convert this into dB. Okay, then you have to use 10 log 2, you get 3 dB. Okay, so this is, okay, kalau you tengok dekat sini, this is considered sebagai gain. Okay, because nilai dia positif. Okay, if you have this one, okay, 0.5, okay, you want to convert it in dB, 10 log 0.5, you get minus. Okay, you get minus 30 dB, which means the value is very small. Okay? Okay? Faham Cara nak tukarnya adalah 10 log nilai yang kita nak tukar. Okay? Okay, lagi satu. Okay, untuk decibel, for decibel, okay, total gain or attenuation, okay, we can calculate by just add the value. Okay, in decibel, in dB, okay, let's say you have a A1 equals to 3 dB, A2 equals to 10 dB, A3 equals to minus 5 dB. Okay, you can get the total gain AT, okay, in dB by adding A1 plus A2 plus A3 in dB. Okay, in dB, you can just add 3 plus 10 minus 5. Okay, but in the absolute value here, you cannot simply add. You have to darab. Okay, you kena bezakan Kalau absolute value, you darab total gain. Kalau dalam dB, you can just tambah saja dB dia. Okay. 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 Decibel. Okay, kalau dalam communication selalunya kita expresskan decibel ni. Okay. Okay, power kita expresskan dalam decibel. Okay, decibel biasa kita tengok dB. Okay, actually dia ada banyak notation. Okay, you have dB watt, you have dBm, you have dB micro. Okay, usually in communication we use dBm because the power value is very small. Okay, dia tak macam kalau dalam electrical, okay, electric power dia tinggi kan. Okay, but this one is very small power. Okay. Okay, so dBm and dBw, okay, kita pakai untuk express power dalam communication. Contohnya, for dBm, okay, untuk dBm, the reference level is 1 milliwatt. Okay, reference level dia maksudnya the denominator dia is 1 milliwatt. Okay, untuk unit yang besar, okay, kita refer pada 1 watt. Okay. Okay, tengok example ni Contohnya, for example, we have 1 milliwatt. Kita ada 1 milliwatt. Okay, we have 1 milliwatt. Okay, kalau kita pakai dBm, okay, kita akan bahagikan dengan 1 milliwatt here. Kalau kita pakai dBm. So, 1 milliwatt divide by 1 milliwatt, you get 1. Log 1 is 0. Okay, then you get 0 dBm here. Okay, what happen if you have 1 milliwatt? Okay, you want to use just for 1 dB watt. It's actually 10 log 10, 1 milli. Okay, so berapa nilai dia? Saya tak ada calculator pula. 10 log 1 milliwatt. You'll get minus, right? Minus what? Minus 30 ke minus 20 eh? 1 kali 10 negatif. Minus 30 kan? Betul tak?
Betul.
Betul eh? So minus 30 dB. Okay, dB sometimes you boleh tulis dB watt ataupun dB saja. Dia sama. Okay, 1 milliwatt, okay, in dB, you'll get minus 30 dB. But if you are using dBm, you'll get 0. You see the difference? Nampak tak perbezaan dia? Kan? Okay, because the value is very small, okay, then kita pakai dBm. We use dBm. Okay? Okay, and this one, okay, 100 milliwatt. 100 milliwatt is actually 1, 2, 1 watt, betul tak? 1 watt kan?
So,
Kan? So 1 watt, okay, you change it to dBm, you will get 30 dBm. Kan? Betul? Okay, you have 1 watt here, okay. Ini equivalent to 1 watt kan? Okay, so 1 watt here, okay, kalau you pakai dBW ataupun dB, okay, you'll get 0 dB. If you use dBm, you get 30 dBm. Okay, so dia ada beza kalau you pakai dBm and dB, dia punya nilai. But if you convert back to linear number, okay, to absolute number, you'll get the same number. But in dBm and dB is different. Okay, so boleh beza dB dengan dBm. Okay, if you want to use a dBm, you have to divide, okay, the value with 1 milli. Okay, if you want to use just dB, you just log the value. Okay? Okay? Okay ke tak ni?
okay, Doktor.
Okay, okay, so cuba yang ini. Okay, just try this a simple example. Okay, you have power in milliwatt. Here is milliwatt. Okay, milliwatt, and then you convert to dBm and dBW. Okay, dBW, or you just put as a dB here. Okay, so sama je kan? Kalau dBW, okay, 10 log 0.01. Then you will get minus. Ni saya salah tulis ke apa ni? Minus 20 dekat.
Dapat minus 50.
Betul lah ni, betul lah ni. Ini betul lah kan? Ini 0.01 milliwatt. Okay. Berapa you dapat? Minus
50.
Minus
50.
50.
Betul kan? Minus 50 kan? Ini minus
Betul.
40 kan?
Minus 40.
Betul, Doktor.
Betul Ini minus
Minus 33.
33.
Berapa?
33.
Minus
Minus
33.
33.
Okay, this one.
Minus
Awak just
30.
pakai
Negatif
10
30.
log P saja kan? Berapa nilai P?
Negatif 30.
Minus 30. This one minus
27.
berapa?
27.
27 eh?
Dia 26.9. 27 lah kan?
27 lah lebih kurang. Okay, yang ini? Minus
20.
20. Minus 20 kan?
Doktor.
Okay, yang ini? Minus 10. Yang ini?
Kosong.
Okay. Okay, so kalau you boleh fulfill table ni maksudnya awak dah boleh buat lah Okay. So yang ini kalau DBM is 10 log P divide by 1 milliwatt. Okay. Nilai P ni awak bahagikan dengan 1 milliwatt. Then you get DBM. Okay. Kalau DB just 10 log P saja you boleh dapat DB kat sini. Okay. Nanti you all boleh cuba untuk DBM sama tak dapat yang ini. Okay. Kalau tak sama tu mungkin you salah tekan calculator. Okay. Okay. Tak ada soalan Kita tengok power ratio. Okay, dB. Okay, kita pakai untuk measure gain, attenuation dan SNR. SNR is a signal noise ratio. Okay, it's a ratio between signal and noise, SNR. And the power ratio in communication selalunya kita pakai express dalam dB. Sama je. 10 log P1 divided by P2. So what is P1, what is P2 depends on kita punya circuit. Okay. For ratio, untuk ratio, okay, macam untuk nilai A, kan, A is the ratio between output with input. So this ratio, there is no unit here. Okay, dia tak ada unit. Okay, but we can express this one in dB. Okay, so to express in dB, okay, let's say we have a voltage input and output. Okay, then we can get the ratio in dB 20 log V out divided by V in. And for current also 20 log I out divided by I in. And for power is 10 log P out divided by P in. Okay, you all kena ingat untuk voltage dengan current, okay, 20 log. Untuk power is 10 log. Okay, so jangan tertukar Kenapa voltage dengan current 20 log? Why voltage and current is 20 log? Kenapa power is 10 log and voltage and current is 20 log? Anyone who know the answer?
Because power equation.
Sebab
Power
P
equation.
equals to V square over R or I square R. Betul? Kan? If you have a P out over P in, okay, you also have a V out over V in kan? So P out equals to V out square divided by R and P in is V in square divided by R. Okay, if you have a ratio P out over P in, okay, you have a ratio V out square divided by R times with R V in square, right? This one cancel, cancel. Now you have V out over V in square. You log this one, okay? So 10 log V out over V in square is equals to 20 log V out over V in. So that's why they have a 20 dekat sini dengan dekat sini. Okay? Rumus ni tahu kan? P equals to V square over R, I square over R. Okay, nanti kita nak pakai banyak lagi ni rumus ni. Okay, so tengok example 1.6. Okay, example 1.6 is a microphone has an output value of minus 50 dBm. Calculate the actual output power. Okay, you all try dulu example 1 dengan 2 ni. Kejap lagi saya sambung Okay, nak habis dah ni. Okay, cuba yang ni. Kejap lagi saya bagi jawapan. Saya nak ambil saya punya calculator jap. Okay, dah siap belum? Okay, you all ada. Okay, dia kata kat sini a microphone ada outputnya minus 50 dBm. Okay, so calculate the actual output in power. Okay, so this one is in a dBm. Okay, you kena anti-logkan nilai ni. Okay, so kalau rumus biasa, okay, you have, 10 log P divide with 1 in dBm, right? 1 milliwatt here. Then equals to dBm. Betul? Okay, so now you have to anti-log this one. Okay. Okay, you have here is, mana saya nak conteng lagi? You have here is log 10 log P divided by 1 milliwatt equals to minus 50 dBm, right? Okay, then log P 1 milliwatt equals to minus 50 dBm divide with 10. 10 ni kan? Then you get minus 5. Okay. Sorry, tak ada 10. Okay, betul lah kan? Okay, now you want to get this one. Okay. Then here is P over 1 milliwatt is equals to anti-log is 10 kuasa minus 5. So, berapa you dapat?
Ten micro.
10 kuasa minus 6, betul? Kan? Then P equals to 10 times, oops, okay, darabkan dengan 1 miliwatt. Okay, dia akan dapat 10 kali 10 negatif 9 watt. Betul? Betul tak?
Betul.
Betul Semua dapat tak?
Doktor, yang tu power mesti dalam watt ke atau tak payah tukar? So macam
Kejap, saya tak dengar lah. Boleh buka lagi tak?
Hello, doktor. Hello.
Ya.
So itu power mesti tukar kepada watt ke atau boleh stay in milliwatt?
Yang mana?
Yang ini power. Yang itu 10 micro punya. Sekarang dia 10 with the power of 9.
Yang ini ke?
Yang itu answer. Yang itu power answer.
Okay. Yang ini
So, yang ini. Ini perlu tukar ke watt ke atau yang perlu boleh stay in milliwatt?
Tak kisah. As long as dia dalam watt, bukan dalam dB.
Okay. Okay, thank you, doktor.
Okay. So semua dapat sama ke?
Dapat.
Okay, kalau semua sama, saya proceed dengan next example. Okay, the next example is you have a 3-stage system, okay, with the input power P in minus 20 dBm, and then the power gains of 3 stages are given in dB, 13 dB, 16 dB, and minus 6 dB. You have to determine the output power, okay, just output power in dBm and milliwatt. Okay, if the answer state in milliwatt, then you have to give the answer in milliwatt. If it's just said in watt or just output power, then it doesn't matter in watt or milliwatt or microwatt. Okay, it depends on the question. Okay. Okay. Saya padam yang ini You dah salin kan? Okay. So now you have 3 cascaded system here. Okay. And the input power is P in equals to minus 20 dBm. Okay. And the A1 is 13 dB. A2 A2 is 16 dB and A3 is minus 6 dB, and you want to get the output power. Okay, so you have to get the total gain AT. Okay, AT for this system is A1 plus with A2 plus with A3. Okay, remember in dB we can just add the gain or attenuation. Okay, then 13 dB plus with 16 dB minus with 6 dB equals to 13 tambah 16 tolak 6. 10, 23 dB. Betul? Betul?
Betul.
Okay. Okay, next is kita nak dapatkan P out. Okay, we want to get P out. Okay, we know that in 80, A equals to P out divided by P in. Okay, so macam mana dapatkan P out? You know the AT, okay, and also P in. Okay, in dB, okay, in dB, P out is equals to A plus with P in dB. Okay, ataupun if you want to change this one into a linear number, okay, also can. Okay, you change a P in what? What you get P in what? Minus 20 dBm, you change to what? What did you get? P in equals to 10 minus 2. Okay, then you darabkan dengan 1 milliwatt. Right. Then you get berapa? You dapat P in berapa watt? You
10-5.
dapat lebih kurang 100 microwatt. Betul tak?
Micro.
Betul tak? 100 microwatt ataupun lebih kurang berapa Berapa milliwatt? 10 milliwatt, betul tak? Kan 10 milliwatt kan? Betul? Minus 20 dBm, you convert to watt, you dapat 10 milliwatt. Right?
Ya, betul.
Kenapa saya tak dengar you all cakap Rasa macam dah.
Doktor, bukan 10 mikro.
Betul
Doktor, bukan 10 mikro ke?
10 mikro
Saya dapat 10 mikro juga.
10 mikro juga Kenapa kalkulator saya ni macam ni? Kejap 10 minus. Semua dapat 10 mikro
Ya, doktor.
Okay, so 10 mikro 10 mikro equivalent tu berapa miliwatt? Sepuluh mikrowatt Berapa
Ya,
miliwatt?
doktor. 0.01.
Berapa?
0.01 miliwatt.
Okay. Okay, so this is your P in. Okay. Okay, try to convert 80 to linear number 80. You have 23 dB. Convert ke. So you have A equals to 10 power of 23 divided by 10. You get 10 23 bahagi 10. 200 betul tak? Betul tak? You all dapat 200 tak?
Doktor, yang itu 23 tak payah tambah dengan itu negatif 20 ke?
Hmm?
Yang itu 23 tak
Hmm?
payah tambah dengan itu power input. So, supaya jadi itu power output.
Dia 23. Dia macam ni kan. Rumus asalnya 10 log P equals to 23 kan. So kita nak dapatkan P ni kan. Right. So nak dapatkan 23 ni, P ni P equals to anti-log 23 bahagikan dengan 10 yang ini kan.
Ya. Ya.
Hmm? Okay. Dapat? Dapat tak 200?
Dapat 199 point something.
Lebih kurang 200 lah saya bundarkan.
Okay.
Okay. Saya bundarkan jadi 200. Okay. 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 Semua boleh follow tak ni? Okay.
Boleh.
So A, kita dapat A kan? A, kita tahu P out sama juga dengan A darabkan dengan P in. Okay. So sama juga dengan A is 200. You darabkan dengan P in. Okay. 0.01 miliwatt. Then you dapat P out equals to 200 times 0.01 milli. You get 2 milliwatt. Right. Dapat tak? Dapat
Dapat, doktor.
Dapat. Okay. So 2 milliwatt. Okay. Kita nak tukar ke dBm. Okay. So untuk tukar ke dBm. Saya bawah sikit So you have P out equals to 2 milliwatt. You want to convert this one to dBm. It will be 10 log 2 milliwatt divided by 1 milliwatt. Then you get berapa? Log 2 bahagi log 2 lah darabkan dengan 10, then you get 3 dBm. Okay. Okay. Okay tak? Dapat tak?
Dapat doktor.
Dapat Okay. Ini dalam dBm kita dapat 3 dBm. Dan dia nak dalam dB watt. dB watt pun kita dah dapat tadi kan? dB watt pula. Milliwatt. So milliwatt is 2 milliwatt. In dBm is 3 dBm. Okay. Faham? Faham? Kalau faham, saya nak tunjuk lagi satu cara. Kita ada 2 cara nak cari. Okay, ini cara pertama. Okay, you tukar semua ke dalam watt dulu. Okay, dalam watt dan dalam absolute number. Okay, maksudnya you convertkan input power ni, okay, daripada dBm ataupun dB you convert ke watt, and you punya attenuation ataupun gain, this A, daripada dB you convert ke absolute value. Okay, you convert ke absolute value you dapat 200. This one you convert you dapat 0.01 milliwatt. Okay, and then you nak dapatkan P out, okay, A times dengan P in. Then you get P out. You will get P out in watt because you change everything to absolute and watt. Okay, so you got P out in watt and then you change back to dBm because the answer, the question one in dBm. Okay, and also milliwatt. Okay, you already got it milliwatt. Okay, and then you convert back to dBm. Okay, you got 3 dBm. Okay, and the second method is, okay, cara yang kedua, okay, we have in dB, right, 80 in dB and also power in dB. Okay, you can get directly, okay, we know that 80 equals to P out divided by P in. Okay, this one is for absolute value, nilai yang tak ada dB. If in dB, kalau dalam dB, okay, 80 in dB, okay, P out divided by P in, if in dB it will become, kalau bahagi dia akan jadi minus. Okay, kalau darab dia akan jadi tambah. Okay, let's say P out equals to 80 times P in. Then in dB it will become P out equals to 80 plus P in. Okay, so sama juga yang ini. We want P out. So P out equals to 80 plus with P in. Kan, this one bring to this side, it will become plus. Then P out in dB equals to 80 plus P in. Okay, we have a P 80. So our 80 is 23 dB. Okay, so equals to 23 dB. Okay, what is our P in? P in is plus with P in is minus 20 dBm. Minus 20 dBm. Okay, okay. Always remember dB and dBm, we can simply plus and minus. Then the final answer will be in dBm, not dB. Okay, then we will get 23 tolak 20 dBm. 23 tolak 20, so 3 dBm. Then you will get directly in dBm here. Sama tak dengan yang ini? Sama kan? Okay. Then you have in dBm, you convert back to dB, to watt. Then you will get, you have 10 log, okay, P divided by 1 milliwatt, okay, equals to 3 dBm. Okay, then P over 1 milliwatt is actually equals to 10. Okay, 3 divided by 10. Okay, P equals to anti-lock here times with 1 milliwatt. Then you will get, awak akan dapat, sama tak jawapannya nanti? Kita tengok 10 kuasa 3 bahagi 10 darabkan dengan 1 ini. Kenapa tak sama? Saya salah kira ke? Anti-lock ke bahagi 10. Okay, darab dengan 1. Okay, awak dapat 2 milliwatt juga. Dapat tak? Dapat?
Dapat.
Dapat.
Dapat Okay. So kalau dapat kita dah habis okay, kita dah habis untuk chapter 1. Ada soalan sebelum saya masuk chapter 2? Ada soalan? Tak ada?
Ya, ada doktor.
Tak ada. Okay, kalau tak ada kita, sekejap